Hello, advanced algebra students, and welcome back to our next video lesson as we begin to explore nth roots, looking at the different roots that rational numbers might have and identifying some of the properties of those roots. And so the next three sections are really looking at problems that look maybe something like this: 27 to the 1/3 power, or 27 to the 2/3, 27 to the negative 2/3, and simplifying, solving. But it's a lot of simplifying these and trying to understand, when do we have two solutions? When do we have one? We go back a little bit to the odd versus even power functions. And so this relates back to powers and roots of a problem. And so I'm going to try and give you, there's really 5 on this page, and try to see if we can't solve these without the use of a calculator or Desmos. All right, the first one: what is the square root of 121? Again, that's looking for the square root of 121. What number times itself? Remember that we could get positive or negative 11. The cube root of 27. So I'm looking for some number, cube meaning 3, a number times itself 3 times, that is 27. The mathematical way to write that might look like this: the cubic root of 27. 2 times 2 times 2, that's 8. 3 times 3 times 3 is 27, so that would be equal to a 3. They might be wondering, well, why don't I put negative 3 here? Well, 3 times 3 times 3 is definitely positive 27, but if I do that with a negative, negative times a negative is positive, but then that positive times the last negative would have given me a negative 27. So I only have the positive there. The cubic, or x cubed, equals 125 over 1 over 27. So if we're going to solve something like that, we take the cubic root of both sides. We take the cubic root, and x equals the cubic root of 125 over the cubic root of 27. Well, we already said the cubic root of 27 is 3. So what number times itself 3 times? X times x times x is 125, and that would be 5. Letter B, if we're going to solve, we want to divide both sides by 4 so that we get x to the 4th equals 16. So some number times itself 4 times. X times x times x times x is 16. Basically, we are looking for the 4th root of 16. That would be 2, positive or negative 2. Last but not least, x squared equals 100. Again, we can take the square root of both sides, and x equals plus or minus 10. Now, if you forgot how that plus and minus 10 works, or why some of them have it and why don't, that's a lot of what we're going to explore here in today's video lesson. Okay, and I really want us to go back maybe into the packet, page number 15. I'm looking at these 5 problems here on the top of the page, and as it really looks at some of this information, we've done some of these in the past, like 1 and 5, right? If I have x squared isolated, I take the square root of both sides, and we get x equals plus or minus 12. If I look at number 5, by taking the square root of both sides, we get x equals square root of 25 over the square root of 64, or 5/8, and we're going to put plus or minus in front of that. All right, so we've done a lot with the squares, but now when we get to those cubic roots or the 4th roots, we're going to use a different process, not a different process, just a different symbol maybe, right? So some number times itself 3 times is 8. That would be x equals 2, right? And we call that the cubic root of 8, where we put a little 3 in the indent. 2 times 2 times 2. Again, we can't use negative. x to the fourth is 81, or the fourth root of 81. Well, 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So that could be 3. Does that work with negatives? And it certainly does, because I've got 4 of them. Negative times negative times negative times negative turns into a positive 81. Cubic root of 64. So how about the cubic root, the third root of 64? 4 times 4 is 16, times another 4 is 64, so that would be a positive 4. So again, we're going to talk about in just a moment why some of these have plus, minus out in front of the answers and which ones don't. Hopefully you can recognize the pattern here, that when we have even powers, we might have, a positive and negative, but if we have an odd power, we probably don't. And we're going to explore why that's the case. But first, I want to talk about this different notation that you might be seeing. What we saw over here was the cubic root of 62, right? That cubic, meaning x times x times x is 62. Okay, what number times itself 3 times? We can also write that as a fraction, right? I could say that that is the same as 62 to the 1/3 power. 62 to the 1/3. And there is some Desmos operations, or functions, I should say, that let you do that, right? You see this button right here, n square root. So you're going to hit that. I want the third root of 62. It gives me some wonky decimal. But what I want to show you is that I could do 62 to the power, and then I'm going to put it inside of parentheses, 1/3, and then close the parenthesis, and you'll notice that we do get the same exact decimal value. So they are equivalents, 62 to the 1/3, or the cubic root of 62. That means 9 to the 1/2 is the same as saying the square root. We don't write the 2 for square root. Or square root of 6 is the same as saying 6 to the 1/2 power. Or basically, whatever is underneath to the power of 1 over whatever numerical value we have for the root, 1 over n. And so they are synonymous. They do have equivalency. Now let's talk back about these even and odd power functions. Hopefully you remember that the even functions both point up in the same direction, or they point down in the same direction, depending on that a value. And we talked about how their domain is going to be all real numbers, and their range is going to be either greater than or less than. Whereas the odd, over here, the odd, their ends point in opposite directions, which is really, really important, okay? When we talk about solutions and when we talk about solving, we are looking for something very specific on a graph, right? Solutions are x-intercepts. Okay, we are looking for x-intercepts on a graph typically when we are thinking about a solution. And when we think about how the graph behaves, or the end behavior, when it goes in the same direction, like if I shifted this entire graph down, it would now cross the x-axis twice, meaning I could possibly have 2 solutions. Same thing if I flipped it upside down. Whereas the odd functions, no matter how I rotate this, no matter which quadrant I start in, this is only ever going to cross the x-axis once, and therefore we will only ever have that one answer. Okay, and let me talk about that a little bit more from a graphing perspective, right? If I have an even power, right, we could have something that has no real solutions because it doesn't actually touch the x-axis, it doesn't intersect. We could also have some of these that, how about I actually draw a parabola that intersect the x-axis twice, meaning it has 2 solutions, right? That's where we get that positive negative value, where we were looking if x squared equals 100, we might graph x squared, and we might graph y equals 100 and figure out where do they intersect, and they'll intersect twice. But these odd-powered functions, on the other hand, no matter how we draw them, no matter which quadrant they start in, this is what we typically were looking at, right? One going this way, the other one going up that way. It only intersected the x-axis once. And no matter how I shift and move this graph left, right, up, or down, if I move the center to here so that we have some sort of a phase shift, notice it still is only going to intercept the x-axis once, meaning we'll only have one real solution. Okay, and that's the idea here behind these roots. Okay, we're going to try and sum it up this way. All right, positive numbers. Okay, if I'm trying to take, for example, the square root of 100, that's a positive number. Okay, positive 100 is going to have two real roots if this n value in here is even, right? It would look like this graph right here, where we do end up getting two solutions. Whereas if I take like the cubic root of 100, or the cubic root of, say, 64, that's a positive number underneath, but an odd n value, an odd root, we're only going to have one real solution because it's only going to intersect the x-axis once. If we are doing this with negative numbers, though, right? If I try to take the square root of negative 100, okay, where the number underneath is even, but it's a negative value, and I try to do the square root or the fourth root, we have no solutions for this one. Okay, if it's even and a negative number, there's no solutions. We can't come up with that. Whereas if it's odd, let's say 2, 4, 8, so negative 8, and we'll try the cubic root of negative 8. Underneath is a negative number, and I have an odd root, we will have one solution, because negative 2 times negative 2 times negative 2 is negative 8. Three negatives multiplied together are still going to give us a negative. And so we get that one real root. No matter what, if we have 0 underneath that square root, remember we only get one real root. Right? That was that discriminant piece. Square root of 0 is 0. Okay, so we get one real root. And this is what we are really, really kind of trying to focus on. Okay, so let me try and write it maybe just a little bit differently. If I am taking the square root of a positive, and this is an even number in here, we have two real solutions. If I'm taking the square root of a positive number, but this is an odd nth root, odd, we have one real answer, one real root. If we are working with negative numbers underneath, if I got a negative value underneath, and this is an even, I'm just going to put E for even, we have no solutions, no roots. But if we're taking the even root, not even, the odd root of a negative number, we will have one real solution. All right, now let's try and put that into practice with just a few of these. The cubic root of negative 8. So the cubic root of negative 8. Odd root of a negative number means we're going to have just one answer, and in this case it's negative 2, because negative 2 times negative 2 times negative 2 is that negative 8. The fourth roots of 16. So the fourth root of 16. We've got a positive number here with an even number. That means we're going to have two real answers, right? I should have 2, meaning I'm going to get positive, negative, whatever fourth root of 16 is. 2 times 2 times 2 times 2. Okay, so 2 times 2 times 2. And so a lot of what you're going to work on today is trying to focus on when do you get one real root or one maybe negative answer, when do you get those two real roots. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe